Swayam Prabha. Digital India. Educated India.
Be able to understand method of preparation and some reactions of an phenol. And again, learner will be able to understand various phenol and its derivative of phenol, structure and their uses. Now we'll see the content of today's session. So in the today's session, so the first point we will be discussing, that is introduction to phenol and its acidity. So in this we will see structure of an phenol also with water, what is an definition of an acidity for an phenol, and how phenol it becomes an acidic with its resonance structure. And so what are the effects of an substituent on acidity, and so also we will see an resonance structure. So there are two classes of an substituent. So one of an class, that is electron withdrawing, and second one, that is electron donating. So what effect does this electron withdrawing group gives on acidity of an phenol, and what does this electron donating group effects on an acidity of phenol. After that we will see some qualitative test for phenols, how chemically phenol it has been identified by utilizing and reagents, And practically also, student will come across such type of an qualitative test for an phenols. After that, we will see some preparation methods of an phenol and some reactions of an phenol. So in this course, you will be coming across there are a lot many reactions which are interrelated. As such, in this also session, we will see some of an reaction that are interrelated with an benzene and its derivative chapter, and some are the reactions for another compound, and some are preparation for another compound. So they will be interrelated, that like a reaction of a phenol with an zinc oxide. So it forms an benzene. So that is a preparation method for an benzene, but it is a reaction method for an phenol. So such kind of a reaction we will find. And after that, structure and uses of phenol and some of its derivative like cresol, naphthals and resorcinol. So now let's see the phenols, what phenols are actually. So till yet we have covered some benzene and its derivative. So little bit modification, or we can say a substitution of an OH group on an benzene ring is said to be an phenol. And we'll see some characteristics of an phenol also. So phenols are acidic due to its ability to lose hydrogen ion, forming stable phenoxide ion in aqueous solution. So this is the structure of an phenol. A benzene ring, it has been substituted by an OH, removing one hydrogen from an carbon. And it is acidic as per an RNS theory. So there are three theories which defines an acids. So one of an theory, that is RNS theory. So RNS theory describes that a molecule or a compound which can lose or which can donate H plus ions are said to be acidic compounds. And in similar fashion, phenol does same thing, that it donates an H plus ion, and so it is said to be an acidic in nature. And it forms an stable phenoxide ion, leaving a negative charge or leaving an electron behind, and now forming an H plus ion. And in phenol molecule, the sp2 hybridized carbon atom of a benzene ring attached directly to a hydroxyl group acts as an electron withdrawing group. So earlier we have seen that all the carbons of an benzene ring, they are sp2 hybridized. In Huckel's rule, we have seen this thing, that all the carbons of an benzene ring, they are sp2 hybridized, and hydroxyl group which is attached to it directly, it acts as an electron withdrawing substituent for this ring. So it withdraws an electron from a ring and forms a negative charge on oxygen. Now we'll come to the point, acidity of phenols. Phenols are much more acidic than alcohols, but less than carboxylic acid or even carbonic acids. So order of an acidity, or how can we define an acidity? So it can be defined by an acidity constant, that is Ka. So now we'll see the acidity of phenols. So approximate value for Ka, it is 10 raised to minus 19. For alcohol, it is 10 raised to minus 18. For carboxylic acid, it is 10 raised to minus 5. For carbonic acid, it is 10 raised to minus 7. Now we'll see the resonating structures of an phenol. So phenoxide ion, which is formed after liberating an H plus ion, and which shows an acidic character after liberating H plus ion, and it is stable due to its resonance form. The negative charge is spread throughout the benzene ring and thereby effectively dispersed. This charge delocalization is stabilizing factor in the phenoxide ion. So after liberating H plus ion or after losing an H plus ion, oxygen has an two lone pair of an electrons earlier, but as soon as it loses an H plus ion, so that H and oxygen, whatever the bond, sigma bond it has been forming between H and OH, so that will break and it will donate a lone pair of an electron, or it will give back a lone pair of an electron towards an oxygen, and it happens due to the fact that oxygen it is an electronegative atom, and that is why whenever the bond it breaks, so it will break towards an oxygen. So the lone pair of an electron, here you can see that oxygen it is having only two lone pair of an electron, and now there is one more additional lone pair of electron having a negative charge. So it is indicating that it is having electrons on an oxygen. So now the lone pair of an electron, so it will be delocalized, and now it will form a double bond between oxygen and carbon. But as soon as this bond will form, a pi bond, it will be formed between carbon and oxygen. The next bond adjacent to an carbon, it will break in the benzene ring, and it will transfer a lone pair of an electron towards an carbon, and now the carbon it will become a negative center. And so this is an arrow which shows an resonating structures of a molecule indicated by two head arrows. So now it has formed a pi bond between carbon and oxygen, now having a two lone pairs as it is, and oxygen it is now satisfied because oxygen has a two valency. Now carbon here it is a negative center, now it will transfer an electron towards and further carbon, and as soon as it happens, so it will transfer an electron towards an next carbon. So here carbon ortho and carbon para, so they are having a negative charges now, so the charge will transfer further, again shown by a resonating structure. And now here you can see that here it was an ortho carbon, now it has become an para carbon carrying a negative charge, and due to which the transfer of electron from an ortho carbon, it has shifted a bond, or it has formed a new bond over here, and this location of this bond has been changed now. So here it can be seen very clearly, and after that again same thing will happen, that a negative charge on the para carbon, so here it will form a bond between metacarbon and para carbon, and now meta and ortho carbon it will break this pi bond and shift the electron towards an ortho carbon. So here it can be seen that now this ortho carbon it is having a negative charge, and as soon as this arrow it indicates that now electrons will be transferred towards this carbon, and it will form a bond, and as soon as the bond will form, so again this pi bond between carbon and oxygen it will break, and it will transfer electron towards an oxygen once again, and it will form an phenoxide ion. Here it can be seen that as soon as it forms a bond, now new bond has been formed, and simultaneously this bond will break between carbon and oxygen pi bond, and now lone pair of an electron it has been transferred on an oxygen, and again here you can see that there are three lone pair of electrons with a negative charge on an oxygen. So by this way phenoxide ion it delocalizes a charge on it, and these are all the resonating structures of an phenoxide ion. Now we'll see the next part, that is effect of acidity, effect of substituents on acidity. So what if any substituent that has been present on an phenol, so what happens to an acidity, whether it increases or decreases? So firstly we will see there are two things that we should know. One is electron withdrawing and second one is electron donating. So in the earlier lectures also we have seen these things, that is what is electron withdrawing groups and what are electron donating groups. So again here we will see this electron withdrawing. So electron withdrawing group on an aromatic ring increases an acid strength, and groups such as nitro, chloro, cyano, aldehyde and carboxylic acid. So these are some electron withdrawing groups, and it is due to the fact that whenever the negative charge on a ring it increases, so acidic strength it decreases, and whenever the positive charge on a ring it increases, the acid strength it increases. And same thing happen because these are electron withdrawing substances. So they will withdraw an electron from an benzene ring, not benzene, phenol over here. So they will withdraw an electron from an phenols, and due to which it forms an electropositive center, and this electropositive center increases an acidic strength of an aromatic ring. So it enables the ring to withdraw more electron from an phenoxy-oxygen and makes it more acidic than phenol. So negative charge on an oxygen of an phenol, so it decreases, and it has been withdrawn by this electron withdrawing group, and which makes a phenol more acidic. So example here I have given that para-nitrophenol is more acidic than phenol. If you look at the structure of an para-nitrophenol, so at the para position having a nitro group, so it is more acidic than phenol, and this is a structure of an phenoxide ion with a nitro group on the para position, and it is due to the fact that this nitro group it withdraws an electron, and this negative charge on oxygen it becomes less, or we can say the electrons are withdrawn from this phenoxy oxygen, and due to which the acidic character of a ring it increases. So now we will see resonance form of an para-nitrophenol. So this is the structure of an phenoxide ion of an nitrophenol. After giving an H plus ion away, so the bond between oxygen and hydrogen it breaks and give away an electron to an oxygen, and it gives a negative charge on that oxygen. And similar in the similar fashion what we have seen the resonance of an phenoxide ion, so similar thing happens over here, that oxygen, now it will form a bond between carbon and oxygen, and the valency of an carbon oxygen it satisfies, and it will break a further bond, and a carbon of an ortho position, now it will form a bond over here, not bond over here, so it will form an electronegative center over here, and as soon as the electronegative center it will form, so further it will be shifted and it will form ortho and meta bond between carbon, and the meta bond and carbon para bond, so it will break, and as soon as it breaks, the negative center at an para position, now it will donate an electron towards a nitrogen, electron deficient nitrogen, which can be seen with a positive charge, and as soon as it happens, the electrons which are coming on a nitrogen, so it shifts or it breaks a bond between nitrogen and oxygen, pi bonded, which breaks, and again the negative centers on both the oxygen it has been formed, and again it will reverse the cycle and it will donate electron towards nitrogen and oxygen, and it will form a double bond, and after which the bond between carbon and nitrogen it will break and form a new bond between these two carbons. And in similar fashion, furthermore, the pi bond between these two carbon it will break and it will shift the electron towards and this ortho carbon, and it will form an electron rich center over here. And in the next step, so it will again form this resonating structure what is shown in the first step. So the bond electron over here it will be shifted between this carbon and it will form a pi bond over here, and this bond will break between carbon and oxygen, and again the phenoxide ion it will be formed. So these are the resonating structures of an para-nitrophenol, and this has an ability to abstract an electron or a lone pair of an electron or withdraw electron from this phenoxide ion. So clearly it can be seen that in over here that electron has been withdrawn from an phenoxide ion or oxygen of an phenoxy group, and due to which the acidity of an para-nitrophenol it is more as compared to an phenol, because this electron withdrawing group increases an acidity on this phenoxy ring. Now we'll see effect of substituent on acidity. So it's next part, that is effect of electron releasing substituents. And electron releasing groups on aromatic ring is acid weakening. So it decreases an acidity of a ring because it avails an negative charge on the ring, and that is why it decreases an acidic strength. And groups such as alkyl, methoxy, amino are electron releasing group, and it is due to the fact that it strengthens the negative charge on phenoxyoxygen and inhibits charge delocalization due to an resonance. So whatever the structures we have seen till yet about an resonance of an phenoxy, so that negative charge when it increases on oxygen, so due to which there is no delocalization of an charge or localization of an electrons, and due to which there is paramethoxyphenol. So here you can see that these are an electron withdrawing substituents, and which increases an acid strength of this phenolic ring. And also here it can be distinguished that nitro group, it is more electron withdrawing, or it has a more electron withdrawing power compared to an halogen or over here. So that it is at the top level. After that it comes a parachlorophenol. It is also an electron withdrawing substituent, and compared to an phenol in between. So these are electron withdrawing substituent, and which makes an acidic character more powerful. But electron donating substituents like cresol and paramethoxyphenol, so these are less acidic compared to an phenol. So most least acidic, it is paramethoxyphenol. So this can be also distinguished, this CH3 alkyl group and methoxy group. So methyl group, it is, we can say it is having a little bit more power of an acidic compared to an paramethoxyphenol. So these both of the groups, they are electron donating groups, and they are least acidic compared to an phenol. So these are some representative structures. So with and related. Again a phenol, and this phenol, it has been precipitated. So here the second observation is that phenol, it has been precipitated. And why it happens actually? Because when it forms an salt form, the sodium phenoxide, it gets solubilized. And now when acid it has been added, so acid HCl, so this HCl, it reacts with an sodium and it forms an sodium chloride plus water, and due to which this sodium chloride, whatever it has been formed, it is more soluble compared to an phenol with water. And whatever the space for an dissolution of an sodium chloride, it has been utilized by this sodium chloride, which has been formed with a reaction with an HCl, and due to which there is no space for an phenol, and either it forms a thick white color or it forms an PPT of an phenol, and from this it can be identified that phenol, it is present in the given sample, or the present sample, it is of an phenol, and it is due to the fact that phenol is not more soluble as compared to an salt in a water, and this salt does not allow an phenol to dissolve, and it will be separated from an water, and due to which it gives a precipitate. Second qualitative test for phenol, that is ferric chloride test. Phenol gives a purple coloration with 1 or 2 drops of a neutral ferric chloride solution, and it is due to a formation of a complex. Actually, whenever there are some phenol derivatives, and you will come across in the practical session also. So such kind of a test, that is ferric chloride test, it is used for a qualitative purpose of an phenol. So identifying phenol. So other derivatives like crisols, resveratrol, they does give an another coloration. So particularly when it is phenol, it gives a purple type of an coloration. So some types of phenol derivatives, it gives an violet coloration. So depending on the phenol, it can be identified what type of an coloration does it give. So here we are talking only about an phenol when it has been, when 2 or 3 drops of neutral ferric chloride it has been added, so it will form an complex, and such kind of an purple color will be given by this compound, and from which phenol can be confirmed. Another test, that is Lieberman test. A phenol reacts with concentrated sulfuric acid and sodium nitrate, forms a yellow color quinone monoxide complex. With excess of phenol, sulfuric acid, a deep blue indophenol complex is formed, and after treatment with sodium hydroxide salt of endophenol is formed, which gives blue color. So here we will see the structure. So phenol, firstly it has been reacted with an sulfuric acid and sodium nitrate, and after that it forms a yellow color compound. So this compound, it is an yellow color, so quinone, because it has been now reduced, sorry, it has been oxidized, quinone monoxide complex, so it is an oxime. preparation of phenols. So the first process, that is Dow process, and it is from chlorobenzene. So phenols can be prepared by from chlorobenzene. In this reaction, hydrolysis of an chlorobenzene with aqueous sodium hydroxide at high temperature and pressure, followed by treatment with dilute HCl. So firstly, how this chlorobenzene it has been prepared. So we have seen in case of an fertile, we have seen this reaction in case of an benzene and its derivative. So by using of an Lewis acid, so benzene it has been halogenated and it forms an chlorobenzene. And after treatment with an aqueous NaOH at high pressure and high temperature, so almost 350 degrees Celsius temperature and 150 atmospheric pressure, so chloro from an benzene it has been removed and it has been substituted by ONA, and this compound it is called sodium phenoxide. And after further hydrolysis it forms an phenol, and this hydrolysis it is done with the help of an acid and water. benzene diazonium chloride with water at 50 degrees Celsius, it forms an phenol. And this reaction of an sodium nitrate, so it from which a benzene diazonium salt or chloride it has been formed. So this is a crucial step because it is carried at 0 degrees Celsius and it has been carried with the help of an ice or in the ice totally, and which forms an benzene diazonium salt. After that, sulfonation of an phenols. When phenol is treated with concentrated sulfuric acid at 20 degrees Celsius, it gives phenol orthophenol sulfonic acid as a main product, and when it is heated at a high temperature, that is 100 degrees Celsius, it gives paraphenol sulfonic acid. Sols, that orthocresol, metacresol, paracresol. So out of that, as per the course, we will see orthocresol. It has antibacterial and insecticidal properties. It has also been used as local antiseptic and disinfectant. But due to its toxicity, or it causes an toxicity in human bodies, so it has made it uses limited. So most preferably, it is not been utilized because of its toxicity. and beta naphthol, or also called 1 naphthol and 2 naphthol. So depending on the position of an OH group, so it is at an first position, so it is said to be an 1 naphthol or alpha naphthol. So naphthols serve as a precursor for drugs such as nadolol, sertraline, and atovaquone. And naphthol is also used in chemical test. So in lot many chemical tests, whether it will be an organic test or whether it will be an biochemical test such as Mollis test. So in lot many pharmacognostic tests, naphthol it has been utilized. So now we'll see a summary of today's session. So we started with phenol, introduction to an phenol and acidity of an phenol. So as per an RNS theory, so phenol has an ability to lose an hydrogen or it can donate an hydrogen, and after that it forms a stable phenoxide ion in an aqueous solution. So that is why phenols are acidic in nature. And also we have seen resonance structure of an phenoxide ion. So how a delocalization of an electrons takes place in a phenoxide ion and which makes it stable, and due to which phenoxides are stable. After that we have seen effects of an substituent. So there are two types of an effects of an substituent. So one of that is electron withdrawing group increases acidity of an phenol, and it is due to that positive center of an phenol it increases, and the electron withdrawing group withdraws an electron from an aromatic ring, and the oxygen on an phenoxy ring it becomes the charge on that phenoxy oxygen it becomes least, and due to which acidity of an phenol increases. And second effect we have seen that electron donating group. So electron donating group it decreases the acidity of phenol, and it is due to the fact that the negative charge on phenoxy oxygen it increases, because electron donating group it will not resonate the structure or delocalize the electrons on an phenoxy oxygen. After that we seen qualitative test for phenols. So first test we seen litmus test. So in the case of a litmus test, a litmus paper, that is blue litmus paper, turns red. Precipitation by HCl, when phenolate has been treated with sodium hydroxide, so it becomes a salt solution and which is soluble, and after precipitation by it has been precipitated by HCl, giving out an phenol once again. After that we have seen ferric chloride test in so few drops of a neutral ferric chloride solution it has been added and it gives a purple color, and for different types of an phenol derivatives it gives a different test or different colors. So in case of an phenol it gives a purple type of an color. After that we have seen Lieberman's test. So in Lieberman test, phenolate is treated with sodium nitrate and sulfuric acid, which forms a yellow color compound, and when it has been treated with sulfuric acid and NaOH, so it forms at last a endophenol, the salt of endophenol, which is blue in color. After that we have seen bromine water test, a tribromophenolate has been formed, and a precipitate of an tribromophenol it has been formed. After that we have seen phthalate dye test. In phthalate dye test, phenolphthalein it has been formed, which is colorless at the end. After that we have seen some preparation methods of an phenol. So first, that is Dow's process. from chlorobenzene, after that cumin from isopropyl benzene, from coal tar, from benzene sulfonic acid and benzene diazonium salt. After that we have seen reactions of phenol such as ester formation, ether formation, nitration, sulfonation and with zinc oxide. And also we have seen structure and uses of phenol and its derivative. So phenol was first, after that orthocresol, after that resorcinol and after that naphthol. So thank you. We have completed module number 2 and lecture number 5.